The program from our last lesson was a little boring. I mean, aren't we programming in 3D? It looked pretty 2D. Well, let's make it more interesting by using transformations and timers to have our shapes spin in 3D. So the way that transformations work in OpenGL is it's kind of like you have a bird that starts out at the origin facing in the negative z direction, and this bird can move, rotate, and even grow and shrink. It's sort of flying around our 3D scene. And whenever you specify a point to OpenGL using GL vertex 3f, this point is relative to the bird. So, for instance, if we were to shrink our bird by a factor of 2, and then move it 2 units to the right from its perspective, then the point 0, 4, 0 relative to the bird would actually be at the point 1, 2, 0. And I'll show you another example. I have it right here using my bird that I made out of silly putty. And we're viewing him from the side. This is the positive z direction, just so we can see things more clearly. So I'm going to take this bird and rotate it 90 degrees. And then I'll move it 2 units up from its perspective. So that's a translation of 0 to 0. And now, if we take a look at this point right here, 1 unit in front of the bird at 0, 0, negative 1 relative to the bird, that point is actually at 0, negative 1, negative 2 in world coordinates. And I have a little picture right here, which lays everything out nice and clearly. So that's the idea behind transformations. And what I'm going to do is take this right here. This is the code from the last lesson, except I removed some of the comments. And I'm going to, first of all, I'd like to point out this right here, this GL load identity. What it does is it resets the bird, so it's at the origin and facing the negative z direction. So what I'm going to do first of all is all of these negative 5s, the z coordinates, I'm going to, instead of doing negative 5 everywhere, I'm just going to translate the bird forward 5 units by calling GL translate f with negative 5 for the z coordinate. And I'm going to change all of these negative 5s to zeros. So the program will look exactly the same when we're done. This is just another way of doing the same thing. And in fact, you might even be wondering why we're doing transformations at all. Why don't we just specify the points directly? Well, that should be clear by the end of this lesson, after we're done. So I'm just changing all of these to zeros, and I want to build the project, and then we'll run it. So here it is. It looks exactly the same as before. It's just done a different way. And now I'm going to add another thing. I'm going to translate to the center of the trapezoid before I specify its points. So I'll just add a call to GL translate f right here. So I'm going to translate down 1 unit to the center of the trapezoid. And then I'm going to change these coordinates right here so that it's drawn in the same way. And actually, what we're going to have to do is we're going to have to save the transformation state right here by calling GL push matrix and restore it down here at the end using GL pop matrix. So, by the way, this name right here, matrix, it comes from the fact that OpenGL uses matrices to represent transformations, and you don't have to know how it does that. I just thought you might want to know where these names come from. And so we have this call right here, which saves the transformation state, and for every call to GL push matrix, we need a corresponding call to GL pop matrix to restore the transformation state. So now let's do the same thing down here with the pentagon. We're going to save the transformation state and translate to the center of the pentagon, which is at 1, 1, 0. And then I'm going to take these coordinates right here and change them up so they are relative to the center of the pentagon. And just gotta change all these numbers real quick. And that's what we're doing for the pentagon. Now we're going to do the same thing for the triangle. And actually what I'm going to do is I'm going to take the one call to GL begin, GL triangles, and split it up into two calls. So I'm going to do GL end here, and down here GL begin, GL triangles. And the reason I'm doing that is because you can't call transformation functions in between a call to GL begin and GL end. You have to do it outside. So for instance, we need this GL pop matrix right here. And also you should note that GL push matrix and GL pop matrix, we don't just get one transformation state that we can save. We actually have a whole stack that we can use of at least 32 different transformation states that we can save. And every call to GL push matrix puts one on the top of that stack, and every call to GL pop matrix will take the transformation state at the top of the stack and restore it and remove it from the stack. So that's what's up there. And right here, I'm going to translate to the center of the triangle at -1, 1, 0. And then change these coordinates right here to match. So again, this is just another way of doing the same thing. Our program should look exactly the same once we run it. And let's take a look. There it is, our trusty old polygons.